Hi everyone, welcome back to my videos. Thank you for all of you that gave me advice on how to get them working again. So today we are going to be talking about drawing polygons on the coordinate plane and how to find the area from these polygons. So I already plotted the first points, so what I would like you to do is pause the video, plot your points, and then remember to find the area of a triangle. Area of a triangle, it is base times height divided by 2. So pause the video and see if you can figure out the area of this and then come back. Alright, so to find the area of a polygon on a coordinate plane, you need to have some lengths that you can actually see, which means you need to have a vertical line and a horizontal line. So with the triangles, your vertical and horizontal line are your base and your height. So we can count it 1, 2, 3, 4, 5. So this is a length of 5, and 1, 2, 3, 4, 5. And that's a length of 5. We could have also looked at the ordered pairs. So here, between 3, 2 and 3, 7, we know that we're going to ignore the 3's, and between 2 and 7 is a length of 5. And then here, between A and C, we're going to ignore the 2's, and between 3 and 8 is a length of 5. So we can use the ordered pairs too. Regardless, now we can use our formula, and yes, I want to see what formula you're using. Our base is 5, our height is 5, and we're going to divide it by 2. So 25 divided by 2 is 12.5. And remember, with area, it's units squared. So our learning target for today is you're going to be able to draw polygons on a coordinate plane and find the area of the shape by the end of the lesson. Alright, hopefully by now you know how to plot points, so if you could please pause and plot your points. Remember, it's x first, then y. X is horizontal, y is how you get to your point vertically. If you could go ahead and plot those points and then restart so we can figure out the area. Alright, so these are the points that I have. Check to see if they're the same as yours. Okay, so it says, what is the best name for this polygon? It is clearly a triangle. And so to find the area of a triangle, its area equals base times height divided by 2. But we're running into a problem because if I look, all of these are diagonal lines, and we learned in our last lesson that you can't find the length of a diagonal line just by counting. So this triangle, we can't find the base and the height. So we're going to have to split this up somehow. So the idea is that we are going to learn different ways to find the area of polygons by splitting up. Now, I didn't draw my lines very well, but I can see if I do, oh goodness gracious, if I do this, I have this small triangle right here. Let me redraw that. That's better. So we have that triangle, and then we can use this as our base, and this is our height for the other triangle. So we're actually going to find the area of two triangles. So this first one, so I'm going to name this triangle 1. So triangle 1, I have my base is 1, and my height is 1, 2, 3, 4, 5, 6 divided by 2. So the area of triangle 1 is 3 units. And then I'm going to go to my triangle 2. And again, my base, 1, 2, 3, 4, 5, 6, right here. My base is 6, and my height is 1, 2, 3, 4, 5. And I have to divide that by 2. So 30 divided by 2 is 15. So that's the area of triangle 2. So all together, it would be 18 units squared. So our goal today is to find different ways, either splitting up the triangles to smaller pieces, or, and I should say splitting up the polygons, or we'll learn a different method where we might put a box around it, like we did in the first part of this unit, and take the pieces away. Okay, so moving on to the second one. If you could please plot these points. This one is going to be a little bit more difficult because there's more points. Give the best name and then come back and we'll determine the area together. Okay, so first please check your points to make sure they're the same as mine. And then I asked you to name this before you came back. I named it quadrilateral because it has 4 sides, but it is not a rectangle or a parallelogram. There are no parallel sides, so the most we can name this is a quadrilateral. Now we have to figure out the area of it. And remember, you need a vertical or a horizontal line to be able to count. And I do see a horizontal line there, but there's not a vertical line to go with it. So we have to split this up somehow or draw a box around. And I think the easiest way that I see is to draw a box around and then take off the parts. So there might be another way to split it up, but for me I just want to show you this way. So I'm going to first find the area of the rectangle. So length times width. So I'm going to count 1, 2, 3, 4, 5. So that is 5. And then my width 1, 2, 3, 4, 5, 6, 7, 8. So 5 times 8 is 40. But now I need to take off different parts. So I'm going to take off this part first. So that's not part of it. So that's a triangle, and so I know that it is base times height divided by 2. So my base is 1, 2, 3, 4, 5, and my height is 5, and I have to divide that by 2, so I'm taking off 25.5. Then I have to, so I'm going to name this triangle 1. Then I have to take off triangle 2, right here. So now my base is 1, 2, 3, and my other height is 1, 2, 3. So triangle 2, again I'm subtracting, because I'm taking it away from the big rectangle, is 3 times 3 divided by 2, which is 9 divided by 2 is 4.5. Then I see, let me change colors here, this rectangle right here that I have to take off. So my length is 2, my width is 1, 2, 3, 4. So length times width, 4 times 2, so I have to take off 8. So that was my rectangle. And so then the last part that we need to take off is this very last triangle right here. 1, 2, 1, 2, 3, 4. And it is a triangle, so we're going to divide it by 2. So 8 divided by 2 is 4. So we are taking all of these pieces off, And so I'll give you a minute to use your calculator to figure that out. Please pause and use a calculator. Okay, as I was doing my calculations, I realized that I made a mistake right here, which many of you probably already caught. 25 divided by 2 is not 25.5. It is 12.5. So I don't know if I said 12.5 but wrote 25.5. But anyway, when I added, the way I figured it is I added all of these that I was subtracting up and then subtracted it. So I came up with 11 units squared once we took everything off. Okay, so this time we couldn't break it into easy pieces, so we put, just to recap, we put a square, or I'm sorry, a rectangle all the way around, and then the pieces that were not part of it, we took off. So we took this piece off, and then we took this piece off, and then we took this piece off, and then we took this piece off. So we were left with the area of the original shape. All right, this type of problem is a little different. Now we are given two of the vertices and the area, and we have to work backwards to find the locations of the other two vertices. So please pause and plot these points. Okay, so I plotted the points, and I know that it's a rectangle with the area of 30. So to find the area of a rectangle, it's length times width. So now we know the area, and we know one of our dimensions, and we have to find the other to help us place the points. This dimension right here is 1, 2, 3, 4, 5. And I could count, or I could use these. The difference between 7 and 2 is 5. So if we are trying to find our width, how long does the width have to be? Well, 5 times 6 is 30, or we could use that solving equations, inverse operations. It's multiplied, so we're going to divide. So we know that it has to be 6. So my other dimension, if I'm drawing a rectangle, I know this one is 5. That means this one has to be 6. So we're just going to draw. I'll go this way first. 1, 2, 3, 4, 5, 6. Like that. 1, 2, 3, 4, 5, 6. And so then we just name these points. So one possibility is this point right here, we'll call it C, is 9, 2. And the other is 9, 7. There is our rectangle with 5 and 6 for the dimensions. Or we could have made it go the other way. We could have had the rectangle going this way. So that's 3 and another 3, 3 and another 3. And then we could have named these points. So I'm going to say this one was C, D, E, F. Or, so we could have had those first two, or E was negative 3, 2. F is negative 3, 7. Okay, so we worked backwards. We used the formula and plugged in what we knew, worked backwards to find the other dimension, and then used what we know about distance on the coordinate plane to find our other points. Whew, okay, hopefully that all made sense. Start your assignment and make sure you ask questions if you have them.